Hi everyone, my name is Marcus and I'm a fuel cell engineer at Spectronik. Today we'll be checking out Spectronik's very own 1000 watt fuel cell, the Protium-1000. Now just to give you guys a brief overview, typical air-cooled fuel cells available in the market are open cathode. What sets our Protium-1000 apart is that it has a closed cathode architecture. This means that our Protium-1000 has, number one, a higher current density. It also has a much better performance over a wider ambient temperature range, and it has a longer operational lifetime. Now, I won't bore you with all the full technical details, but if you're really into fuel cells like me, check out this article written by Unmanned Systems Technology. They have a full technical description of the advantages of our closed cathode air-cooled fuel cell technology. We'll link the article in the description down below. Here at Spectronik, we always prioritize the end user experience. This means when we ship out the Protium-1000, it will come with its own custom protective aluminum rack. You can use this rack for any benchtop testing that you want to carry out. The Protium-1000 also has these mounting points. You can use these mounting points to integrate the Protium-1000 into your application. Now let's take a look at the other unique features of the Protium-1000. We have multiple sensors located throughout the stack that detect parameters such as stack temperature and gas pressure. We have a dedicated blower to force oxidant into the cathode channels of the stack. Next, we have two cooling fans in the rear that draw air through the stack. We also have integrated valves to dynamically control the gas purge cycle, as well as protect the stack against overpressure. Now it's time to see the Protium-1000 in action. First, we gotta do the setup. It's really easy, no tools required. First, connect the hydrogen supply into the gas inlet connector. Next, connect your purge tubing to the gas outlet connector. Be sure to direct the purge tubing to the rear of the fuel cell, away from the blower inlet. After that, connect a startup power supply or battery to the fuel cell controller. Finally, take your load cable and connect it to the fuel cell controller. We've also made a user-friendly PC app that can communicate with the fuel cell wirelessly. We use this modem right here that has a range of up to 10 kilometers. Now to start up the fuel cell, click the S button and click Start. Now we're ready to supply the hydrogen. The fuel cell will do a series of checks. Be sure to regulate your hydrogen from 0.5 to 0.7 bar gauge. Yep, and now we're live. Now we're ready to turn on our load. I'm going to increase the load to a maximum of 1000 watts or a minimum of 18 volts. As you can see, we have reached 1000 watts. The PC app has three main functions. First, you can monitor the status of the fuel cell through it. You can also receive warning messages if there is an error. Next, you can remotely control your fuel cell. I can do things such as increase the fan speed. I can also activate a manual purge. Finally, you can log operation data just by clicking this save icon here. Give it a name of your choice, and it will be saved onto your desktop as a CSV file. This CSV file can be reopened later for post-processing. To stop recording the data, just click on the save icon again. Well, that just about brings me to the end of the video. If you like what you see, check out our website at spectronik.com. You can also drop us an email at hello@spectronik.com. You can download the PC app and our product manuals from our website as well. All of it will be linked in the description down below. While you're there, give us a like and subscribe for more fuel cell content in the future. I'll see you guys in the next one. Bye!